Okay, let's go ahead and complete this. We're on chapter 18. This is looking at lenses and mirrors. So virtual versus real image with a plane, concave, and convex mirror. So plane mirror, if you remember, plane mirror is a flat mirror. And if your object is over here, your image is actually going to be on the inside. This is section 18.1. So always, always, always with a plane mirror, you're going to be having a virtual image. And it will be the same distance that it is away from the mirror. So in this case, the distance of the image, the negative distance of the image will equal the distance of the object, and the height of the image will be equal to the height of the object. Okay, let's go to concave mirrors. We actually didn't do convex mirrors, so we'll cross those off. With a concave mirror, we draw a concave mirror here. Actually, we did do convex mirrors. We didn't do convex lenses. We'll have to get to that. My bad. So we have our principal axis. We have that perpendicular. And you have, if you're outside, here's the center. We're just going to be even outside the center. Here's your object. Okay, we're going to have our first come in like this. That means our focal point will be right about here, if that's the center. It's going to go through the focal point. This goes through the focal point and then comes out like this. So with a convex mirror, the distance is always going to be positive. So you're going to have a positive distance of the image when you're outside the focal point. And in this case, it's going to be a real image as well. Your height is going to be negative, so you have a negative height of your image. But you will have a real image because the light rays actually converge. Remember, the closer that you get to your focal point, the larger that it's going to get. And then when you pass on the inside of your focal point, so here's your mirror, here's your principal axis, your perpendicular, let's put the focal point there. So now if we're on the inside of the focal point, okay, this is a mirror, so what's going to happen is this is going to come in parallel to the line, and it's going to come out through the focal point. The second one's going to be lining up parallel to lining up with the focal point and then reflecting off and coming out parallel. Those two will never converge, and so we're going to be creating sight lines and a larger object. So for this, the distance of the image is going to be negative. The height of the image is going to be positive, and it will always be a virtual larger image when you're inside the focal point. Okay, the image with outside the focal point depends upon your distance. The farther away you are from the focal point, the smaller it's going to be. The closer you are, the larger that it's going to be. Okay, let's take a look at the concave mirror. My bad. So let's put the concave mirror over here. And here's your principal axis. And let's put the curvature like this, and your object is going to be over here. And remember, since the curvature is going the other way, your focal point is going to be on the other side of the mirror. So you actually have a negative focal point for this. Let's go ahead and see if we can do this. This is a mirror, so images coming in parallel will reflect oriented to the focal point. And then we have those that are going in toward the focal point. We're going to reflect off parallel. Those are diverging rays. They will never meet. So we go backward with those sight lines from the reflected rays. And with this, the distance of the image is going to be negative. The height is always going to be positive. And it's always going to be smaller. With a convex lens like that, there's no way to get a larger image. So in this case, they are real when you're outside the focal point. When you're inside the focal point of a concave mirror, it's going to be virtual. For convex mirrors, there will always be smaller, and of course they will be virtual as well, since they are the sight lines and they're not going to be having the light rays actually converge. So whether an erect or inverted or smaller or larger image will appear with a plane, concave, or convex mirror. Okay, so I think we covered all these. Let's see. So a couple other points. The closer to the focal point, that will produce a larger image. And with plane mirrors, it's going to be, there is no focal point. And with plane mirrors, it's going to be, as we had discussed, it's going to be the same size. It's going to be just a negative distance. With concave mirrors, okay, you're going to be, again, closer to the focal point will produce larger. And the closer you're to the focal point, it's going to be larger. The farther away, you're going to be smaller. And that happens in both cases. With the, if you're outside the focal point and you're very, very close to it, it's going to be large. If you're inside the focal point, it's going to be very, very large. The closer that you get to the mirror, the smaller it's going to be. So this image, as you get closer to the mirror, will appear closer as well, but it's going to be smaller. The farther away that you go, it's going to get larger. So the concave is going to vary. And the convex, as we discussed over here, is always going to be virtual and smaller. Okay, on to the next. Know when the focal point is, the DI or HI is positive or negative with a plane, concave. I think we've covered all those three as well. So there is no focal point with a plane mirror. With concave mirror, the focal point is positive. The distance of the image is always going to be positive when you're outside the focal point. So for concave, outside the focal point means that you're going to have a positive DI and a negative HI. When you're inside the focal point, it's going to be a negative DI, virtual image, but it's going to be an erect image, positive HI. Convex mirrors, it doesn't change. Convex mirrors, you always have negative focal points, negative distances, and they're going to be upright or erect. Relationship between the focal point and the radius. The focal point is going to be half the radius. What happens to your lens when looking close or far away? We didn't do this one. We didn't get to that because of our limitation. What happens to the size of the image when approaching or passing the focal point of a concave mirror? So we sort of already discussed this, but what happens to the size of the image when approaching and passing a focal point? So concave mirror, image starts to get larger. And when you're passing the focal point, you're going to then invert the image. Okay, so if you're inverted, it becomes erect. If it becomes erect, it becomes inverted. Okay, so use the lens mirror equation to calculate these guys here, distance of object or distance of the image. Remember, you can rearrange by subtracting both sides. Use the magnification. So oftentimes, you're given the distance of the object and you're most likely going to calculate the distance of the image. So you're going to be subtracting 1 over DO from both sides, or 1 over DO both sides. That will give you the inverse of this. And remember to use the button on your calculator, which means inverse. So once you get your answer, you have to take the inverse of the answer. Use magnification equations. This is often used to find the height of the image because there's no height in the image right here for the lens mirror formula. Draw where the image appears for a plane mirror. Okay, so for a plane mirror, concave mirror, or convex mirror. So for a plane mirror, if your object is here, remember we drew these rays like this, kind of going like that, reflecting off of the mirror, and they would converge as a virtual image on the other side. We've already done that for our concave mirror and for our convex mirror. Draw where the image appears for a convex lens. Go ahead and cross that one off because we didn't have time for sight. But if we have our lens, here's our convex lens. Remember, there's focal points on both sides. So if my object is here, instead of reflecting off the mirror, it's going to go through like this. Those that go through the focal point will come out parallel, and that's where the image will appear on the other side. You can also, don't forget, you can also go right through the center of the lens as well.